Hello everyone, welcome to educational channel, and this is Srinan. So today we are going to learn about a new topic in maths, coordinate geometry. Okay, let's start. Let's start with the word coordinate. Okay, what is a coordinate? Coordinate is something which helps us to understand the location of something. For example, you see, I am keeping a point somewhere in this plane, somewhere here. Let's say this one, okay? This one is the point. Now, I need to define the location of this point. Okay, I don't know where it is. What is the distance of the point from the x-axis or y-axis? Yeah, I don't know anything. Then how can I refer to the distance of the point? It's a very simple thing. I don't know what is the distance. So I will call the distance of the point from the x-axis as y. Because this is the distance and this is the y-axis. We have to learn about axis. What is axis? This whole thing is an axis. This whole thing is an axis also. Now, in an axis, there are two ends in this coordinate axis. This is the negative end and this is the positive end. This is the negative end and this is the positive end. Okay? And the intersection point of these axes is the origin, which is represented by 0, 0. Okay? That is called the origin. And we define the location of points with the coordinates as abscissa and ordinate. What is an abscissa? The x coordinate. What is the ordinate? Y coordinate. Let me explain it to you. Wait. Let's take the point as 2, 3. Just for illustration. 2, 3. Now this is abscissa. And this is ordinate. Okay? X coordinate, abscissa, y coordinate, ordinate. Okay, just for illustration purpose. And now, I need to define the location of this point. I don't know what this point is. And we have to know this quadrants especially, because these quadrants decide the sign convention of the points. You see, I can keep the same point here, here or here. But what is the difference? The sign and the magnitude. Okay, I will explain it to you. So, if you take two lines, intersect them and put it on a plane, then those lines divide the plane into 4 parts, right? Logically, these are two lines, right? This is the whole plane or space. You put it there and it divides the space into 4 parts. 4 parts. So what is 4? Quad. Quad means 4. And if this whole thing is space, this one is called a quarter. Quadrant. So this is a quadrant. So we are naming these quadrants for our convenience as first quadrant, second, third and fourth respectively. And now we have to know the sign convention. Okay, now if you want to represent a point somewhere, if you want to represent a point, you have to take the distance of the point from the x-axis and y-axis respectively, right? From the origin, that's the point. Now, if I want to take this point from origin O, we have to note it as O, denote it as O. From O, what is the distance of this point? Okay, let's draw it. Draw the distance. Now, this one, okay, this is the vertical distance and this is the horizontal distance. Okay, I don't know what this point is. I am naming it as x comma y. Why x comma y? I don't know the distance. So I am naming the distance of the point from here as x. Okay. And I don't know this distance also, right? I am naming it as y. Okay? Y. This is the actual representation of a point. If you want to represent it from the origin, taken as 0, 0. Okay? Now you are taking it like this. On the path to the complexity of this geometry, let's learn a few basic concepts which we will need in the future. For example, like locus and change of axis, straight lines, parabolic equations, etc. Now, we have to find out the distance between 2 points. Okay, we have two cases. The distance between two distinct points where both of the points are not origin and any one of the points is also not origin. And another case, one point is origin, another point is something else. We don't know. Okay, now we are going to go with the second case as I explained. That will be easier, and then we will move on to this first case because that one is a little bit complex. We will be able to understand it easily, but this one is a little bit easier, the second one. Okay, I want to find out the distance between this 0, 0 origin and this one. You see, if you want to find the distance between 2 points, you have to draw a straight line. That's the rule, the straight line. So I am going to draw a straight line here. Okay? Yeah. And I want to know this distance. So I can denote the distance as d. Okay? For my convenience, I am denoting it as d. Now I need to find out this d in terms of x and y because I have x and y, right? I have only x and y. So we are going to start by using what? First we will extend the axis. Okay, we will extend the axis. Now I am drawing a line, a perpendicular line to x-axis because we are gonna check the perpendicular distances only. You cannot have any kind of distance because from this point to its actual x-coordinate you can draw only a single line, that too it's a perpendicular one. Because if I take any other inclination, it will land up somewhere here, right? I will not reach this particular point. This is what I need, right? So this point is x, this point is y. Simple, right? Okay. Now, it has to be perpendicular to reach the point, right? So this one is perpendicular, right? According to the logic. This one is also perpendicular. Now what should we find out? This one. See, how many sides are there in this one alone? 1, 2, 3. It's a triangle. And you have a right angle here, 90 degrees. So what is it? A right angle triangle. Okay? If it's a right angle triangle and you want to find out the hypotenuse and you have two sides, ask me where are the sides? This side is x, right? And this side is the same length as this side, right? Then this is y, this is also y, because if this is perpendicular to x-axis, this line must be parallel to y-axis, right? So this is also y. Now I have two sides, find out one. Using the Pythagoras theorem, square of the hypotenuse, square of hypotenuse is equal to squares of the remaining sides, x square plus y square. What do you need? I need d. This is the square of distances between the points, but I need the distance itself. So I have to take the square root. Now I am taking the square root. Square and square root get cancelled. And don't ask me x square and y square are there, so we can cancel the squares. No, this is just x square plus y square. So if we cancel the squares, it must be x plus y. That's a wrong answer. x square plus y square plus 2xy whole to the power of 1 by 2 or the square root gives us x plus y. You don't have a plus 2xy term here, right? So your answer will be wrong. The correct answer, the correct distance between x comma y and 0 is square root of x square plus y square, or you can write the square root as x square plus y square whole to the power of 1 by 2, because this is square root. If you have a cube root, 1 by 3, fourth root, 1 by 4, etc. It will go on forever. And this is the distance for finding the distance between 2 points. Now we have to find out the distance between the 2 points, the first case. Okay, I will erase this. And let the point be the same, but I'm gonna make a few changes, or let it be like that itself, no problem. Now I'm gonna change a few things and I will add another point which is not origin, or else it will be the same as our second case, right? The case we just discussed. Okay, now let it be the same. Yeah, okay. Now we will add a new point, a comma b, right? No problem, right? A comma b. Okay. Now a comma b, the same thing we have to take parallel to the x-axis and parallel lines to the y-axis so that it will be perpendicular, right? It would suit the most. Okay. This length is the vertical length, right? Yeah, so this length will be b, so this side will be b, right? Now I am joining, this will be a, right? Logically a, x coordinate, and this length will be b. Okay, now we have to, think a little bit more logically. Let's start. Very simple. Now you have to find out the distance between this point P1, let's call it as P1, and P2. Okay, point 1 and point 2. How to find out? So this is the distance what we have to find out, right? I will highlight it in another color. This is the distance. Okay, so this is the distance L, we can call it as L, right? L. Now we have to find out this one. Okay, now what if I join, I extend this line segment over here. I'm going to extend it to a little bit, see, I will just draw a line here. Okay, and now what do you have? A right angle triangle, because you see in the last diagram, the previous diagram, I have erased a few points, right? In that same diagram, these are perpendicular and parallel to their opposite axis, right? That means if I extend the same line throughout the same inclination, then I will get the same perpendicular angle, right? Simple. So this must be a right angle. Over. Ignore everything. See this part alone. What is this? A right angle triangle again. So we can use the Pythagoras theorem. Wait, how can we use it? We don't have two sides, right? But actually we have two sides. We have to think it in a much better way. You see? Or else I will draw it in neatly. 1 minute. What is this total length? It's B, right? Of course B. B, total length is B. We have to understand that one. Then it will be easier. It's B. And now, what is this length? Did you see something? Y. Yeah, it's Y. Okay, and now this one is x, right? Now what is this length? A, right? A, x. Now what do you want? I have this same side as this one, right? So this side can be, I'll call it, no need of complications, okay? Now, this is A, this is x, then what will be this length? A minus x, right? So this length is A minus x, logically speaking, yeah? A minus x. If this is A minus x, this is A minus x. Simple. And now what is this length? Total length is b, a small part of it is y, then the remaining will be b minus y, right? Or else for cross checking you can add it. This total length will be equal to this total length, x plus a minus x. Minus x plus x cancel, a gives rise to a. Similarly for b also. Simple. Now you have to use Pythagoras theorem. You have the two sides. So L is equal to, we have one side as a minus x, it's L square. A minus x whole square plus b minus y whole square. And if you take the square root, right? Take the square root, because you need the L, not the L squared. So square and square root get cancel. L is equal to square root of a minus x whole square plus b minus y whole square. Okay, that's it. So what is the difference between the second and first? Simple. In the second formula you have a or b as 0, 0. Why did I say a or b? Because if you substitute 0 anywhere, if a is 0, then minus x whole square, b is 0, minus y whole square. But if you square negative terms of the same magnitude as positive terms, you will get the same answer because it's a square. Squaring is a positive function, right? That means I can take any order. Root over a minus x, b minus y is there, right? I can take it as x minus a and y minus b also, because you're just squaring it, right? There's no problem in that. You will not get negative numbers, right? Simple. So this is the formula, and that's it for today. Make sure you drop a like and subscribe to my channel, watch my videos, and then share it to others. Thank you.